Good afternoon, everyone. Welcome to Data Science Connect Atlanta. I'm really happy to be here speaking to all of you this afternoon. So I'd like to talk to you today about Augmented Analytics. And the title of my presentation is Carpe Datum Seize the Data. So I will do some introduction. I will explain augmented analytics. I will talk about the benefits, and then I will go over a use case. A little bit about NCR. So we are here in Midtown Atlanta, and we've been here in business 136 years. We're a technology company, US top 100 technology innovator. And chances are that if you have gone to an ATM recently and withdrawn any money, or if you've been to a fast food restaurant and ordered any food online, or if you have used mobile banking application on your phone, chances are you have interacted with us. And for that, we are really happy. So I'd like to talk about a scenario, and this is very applicable in today's world, actually. So today is October 8th, 2020. You are a busy working mother. You are juggling a million things. You have children who are in virtual school. You have your home office, you are working, you're on conference calls. The children are knocking on your door, telling you the internet is slow. Your washing machine is broken because it's being overused. What you really need is a haircut because, we all want to look good. You don't have time to schedule an appointment. And so what you do is you ask your virtual assistant to schedule an appointment for you between 10 a.m. and noon. And what I want to play now is an exchange of what happens when you do that.
So how can I help you? Hi, I'm calling to book a woman's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have a 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks, great. Have a great day. Bye.
So this example really illustrates that the virtual assistant has come such a long way. They were able to use context, they were able to think on their feet, and the person at the hair salon that made the appointment didn't even know that they were speaking to a virtual assistant. Simply amazing. I do want to touch on when AI technology can have extreme outreach. One example is facial recognition. Facial recognition is starting to get widely used. Cameras are linking to our personal profiles. What if that technology is not used responsibly? What if they can track your movement and, for example, know where you have been for the last 1 week. They know exactly what you've done. So this is an example of where we want AI to be used judiciously and with the right ethics. So what is augmented analytics? Augmented analytics is where artificial intelligence and machine learning are used to drive the analytics. It automates insights by using techniques from both AI and machine learning, and it uses it across the entire analytics lifecycle. And you can start to find insights faster. You start working with the data in a more natural way using conversational AI. And what is important is that it's forcing us to become smarter about how we are looking at our data and how we can now make better business decisions. Here is a picture of a traditional business intelligence lifecycle. This is now muscle memory for several of us. You connect to the data source, you get the data, you do data preparation, you perform the analysis, you write the rules, you then make the data available in a report or dashboard, and you distribute the information. The augmented analytics cycle is a little bit different. What happens is when you start to use this to look at the data, the algorithms detect the schemas. They're able to catalog the metadata. They're able to tag it. Sometimes it can even recommend the enrichment that you can perform by adding other data sets. You can use natural language queries to interrogate the data. Algorithms can find relevant patterns, and a lot of times the automated machine learning can be used to generate the models. And most importantly, the insights can be narrated in a natural language, and your visualizations are now forcing your user to start thinking on what is the right action that they can take for an improved business outcome. So augmented analytics is really rapidly analyzing all data across all possible dimensional combinations. And it's identifying factors that can help to contribute to the growth of your company. What is an example? One example could be anomaly detection. If you have the algorithm running in the background, it can automatically detect the anomalies and present it to a team of users whose job it is to monitor such anomalies. It can do trend detection. If you have teams that are constantly looking for trends to then take the right action, this is another example of where you can use augmented analytics. The most important is that you should be able to deliver the insights and then track how those insights are being used. Because at the end of the day, if everything that you do isn't used and you're not getting the right outcome and return on investment, then really it's of no value. So I want to talk about cognitive computing, which is a phrase that you will often hear. So earlier I talked about speech recognition, sentiment analysis, facial profiling. All of this falls in that discipline of cognitive computing. It's the ability to analyze, interpret, learn, and simulate human intelligence. So I'd like to talk to you about specifically what is NLP, or natural language processing. It is the field of artificial intelligence which gives machines the ability to read, understand, and derive meaning and context from human languages. Notice that I've highlighted the word context because context is so important. And I will illustrate it in the next slide. So when you ask your virtual assistant to play rock, I'm sure you're going to wonder at one point, how is it that your virtual assistant is not thinking that play rock means taking two pieces of rock and playing with it? How does your virtual assistant know that what they actually need to do is this? So the virtual assistant is able to apply context, think like us, and know that when you say play rock, that they should actually play rock music. How does it do that? If you want to do this development in-house, there's pre-trained models out there. I will cover 4 of them. And the first one is OpenAI's GT3. So this large-scale transformer-based language model has been trained on 175 billion parameters, and it's quite popular. Another one, which is very famous, is Google's BERT, and this is an NLP model that was developed by Google in 2018, and it has been tested against the competitive Stanford question data set. Another one is Microsoft's Google BERT, and this took Google's BERT and it actually built more, it enhanced it more. It's a bidirectional multi-layer neural architecture for both code search and code generation. And finally, another one is Elmo. So these are just examples. There's many more, but I thought I would touch on 4 of the big ones. I now want to explain what is NLG, which is different from NLP. NLG stands for Natural Language Generation. And this is something that's going to be really useful for organizations to scale analytics. So what it does is the software translates structured data into narratives, and it starts to explain that data in a human-like manner at a rapid pace. And it's creating linguistically rich descriptions of the insights that's found in this data. And there's enormous potential here because it can really help you scale your analytics. I will touch on a few NLG models. One is Markov. This was one of the first algorithms that was used, and it predicts the next word in the sentence by using the current word and considering relationships between the unique words. And then it calculates the probability of the next word. Another one is Recurrent Neural Network, RNN. And it tries to really mimic the operation of the human brain. And then the other one is LSTM, long-term, short-term memory. And this has taken RNN and expanded it even further. And finally, there's Transformer, which is a stack of encoders for processing inputs of any length, and another set for decoding the output. So these are the NLG models. Why NLG? As I said before, it's really ideal for increasing data literacy in an organization. Because as you all know, we are all taking our data, we're creating reports, we're creating dashboards. But we want to be able to scale that analytics so everyone can understand the insights. And so I offer you this. Seize your data, scale your analytics. I want to quickly go over a use case that we are working on currently, and we are in the midst of this. So what we thought is let's evaluate the NLG tools that are out there and put it against our most frequently used dashboards to see what insights it can generate. In our particular use case, we have analysts that spend time and they take these frequently used dashboards and they're actually creating the insights and they're preparing the commentary in preparation for the monthly meetings. And we thought, why not see if this tool can generate some of these insights, and it'll really help to create one consistent message. What I'm showing here is the Forrester New Wave, which has a list of all the top technology vendors that are in the NLG space. I'll pause here for a minute so you can look at it. So the use case that the problem that we were trying to solve in our use case was, how do we reduce time to insight and action? And how do we eliminate misinterpretation and incorrect action? If you're an analyst that is the author of the dashboard, you're going to be getting a lot of questions from people all across at the end of the month when that dashboard has all the data. And everyone is asking you for the interpretation. Executives typically really don't have much time, and oftentimes they will ask you to create a PowerPoint to show the insight. And so what you want to do is create this insight that is consistent for everyone to look at. So based on the work that we've done so far, we're seeing really good results. We're finding that when these tools, which have extensions with data visualizations such as Tableau, Power BI, and other tools, it can generate a dynamic narrative that then becomes part of the data visualization. It is contextual, and it's almost like the subject matter expert is sitting and has written it down. And what is important is that when you're using these tools, obviously it has to be against a dashboard that you have created. So our POC specifically has been against dashboards. So we're seeing a lot of promise in this technology. And so I'd like to conclude by saying, Carpe Datum, seize the data. There's so much data out there. Don't let it go to waste. Create compelling data visualizations and use natural language generation to make your data easy to understand. So with that, thank you so much for attending my session.